First, let's start with the basics. What is an electronic nose exactly? Well, as the name suggests, it's a device that mimics the human sense of smell. It's made up of various sensors that detect and analyze the chemical composition of the air, allowing it to identify different odors and fragrances. Now, you might be wondering why we need electronic noses when we already have the real thing. The truth is, human noses are incredibly complex and sensitive, but they have their limitations. For one, our sense of smell can be easily overwhelmed by strong odors, making it difficult to pick up on more subtle scents. Additionally, we all have different thresholds for different smells. So what smells pleasant to one person may be unbearable to another. Electronic noses, on the other hand, are designed to be more consistent and reliable. They can detect a wider range of smells and are not affected by things like fatigue or personal preference. This makes them incredibly useful in a variety of fields, from food and beverage manufacturing to environmental monitoring and even healthcare. Volatile organic compounds are chemicals emitted as gases that can have adverse health effects. They are often found in paints, pharmaceuticals, and refrigerants, among other common products. But they can also act as markers of explosives, insect infestation, food spoilage, and disease. Tracing VOCs is important for public safety and all smell-related issues. To this end, in Applied Physics Reviews from AIP Publishing, Liu et al., introduced a fluid mechanics-based chamber design for an electronic nose, enose, that consistently detects VOCs at low concentrations. The strategy, which includes using a shunt-like device to control the behavior of fluid flow, is a step forward in enose technology development. Methods for detecting VOCs face many challenges in terms of selectivity, sensitivity, reproducibility, and stability. E-noses, inspired by the olfactory system, can overcome some of these barriers by combining arrays of chemical sensors with pattern recognition techniques to recognize odors. Now we see it's all about the sensors. Each sensor is designed to detect a specific type of molecule, and when these molecules come into contact with the sensor, a chemical reaction occurs. This reaction produces an electrical signal, which can then be analyzed and interpreted by the device's software. Of course, designing an electronic nose that can accurately detect and identify a wide range of smells is no easy feat. It requires a deep understanding of chemistry, physics, and even neuroscience. Researchers must carefully select the right sensors and optimize their sensitivity and accuracy. They need to develop algorithms that can quickly and efficiently analyze the data generated by the sensors. And they have to take into account all of the different variables that can affect how smells are perceived, such as temperature, humidity, and air pressure. One exciting application of electronic noses is in the food and beverage industry. Companies can use electronic noses to test the quality and safety of their products. For example, an electronic nose could detect when a batch of beer has become contaminated with harmful bacteria, allowing the manufacturer to take corrective action before it reaches consumers. Electronic noses also have the potential to revolutionize healthcare. In fact, researchers are already exploring the use of electronic noses to detect diseases like cancer and diabetes. It turns out that many diseases can produce distinct odors, which can be picked up by an electronic nose. By analyzing these odors, doctors may be able to quickly and accurately diagnose diseases, potentially saving countless lives. But perhaps the most exciting application of electronic noses is in environmental monitoring. By deploying electronic noses throughout a city or region, researchers can gather data on air quality and identify potential sources of pollution. This could allow local governments to take action to reduce pollution and improve public health. Of course, there are still many challenges that must be overcome before electronic noses become widely adopted. For one, the technology is still relatively expensive and complex. This means that it's not yet feasible to deploy electronic noses on a large scale. Additionally, there are concerns around data privacy and the potential for these devices to be used for surveillance purposes. Nonetheless, the potential advantages are too great to ignore, and researchers are working hard to address these issues. A wide variety of sensor technologies are utilized in modern agriculture and forestry to obtain accurate information on crop, soil, weather, and environmental conditions. Sensing tools are used in these industries for a multitude of applications in the manufacturing of agricultural and forest products, particularly for quality control and monitoring industrial processes. Agricultural and forestry management methods strongly rely on a spectrum of sensor technologies ranging from aerial remote sensing, portable field weather stations, greenhouse environmental sensors, electrochemical sensors, electronic noses, biosensors, and sophisticated wireless sensor networks. 1. Electronic nose devices are being used with increasing frequency because they allow the acquisition of real-time information about the chemical and physical nature and quality of plants, plant and animal products, and gas effluents released from agricultural and forestry products throughout the entire food and fiber production cycle. The continuous monitoring capability of enose devices provides a means of assuring that production methods and outcomes meet quality specifications, standards, and demands required by regulatory agencies and the consumer for ultimate salability in commercial markets. The invention of diverse electronic nose (enose) sensor types and instruments, based on different electronic aroma detection (EAD) principles and mechanisms, has led to the development of enose applications for diverse disciplines within the plant sciences. 2. Gas sensing applications utilizing enose devices in agriculture and forestry are naturally divided into two major groups, including those developed for commercial and industrial applications of products derived from 1. Small non-woody, herbaceous plants, used as agronomic crop, food plants, and animals within the agricultural industry, and from 2. Larger woody plants used as ornamentals, landscape structure, fiber, or wood production within the forestry industry. Thus, the agriculture and forestry industries handle the majority of plant and plant-derived products that originate from wild and domesticated plant species throughout the world. The industrial sectors comprising each of these two plant product-associated industries are vast due to the large number of plant species and product types that are exploited by world commerce. Animal-derived products in agricultural are primarily derived from the commercial meat-producing industries. The starting enose design featured a vertical chamber that looks much like a shower head. This promotes vertical flow as gas spreads through holes at the bottom of the device and around to evenly distributed sensors. Using fluid mechanics simulations, the team optimized the volume, symmetry, hole location, and sensor location of their enose chamber. They added a shunt-like device to promote fluid flow and shorten response time. Based on their simulation results, the researchers fabricated a Teflon chamber and measured the sensing performance of their enose. They compared two chambers, one with the shunt and one without. The chamber with the shunt device consistently performed around 1.3 times better at sensing an example VOC. In the future, the authors plan to focus on minimizing the chamber and improving the structure further to decrease response and recovery time. Enose research is a highly interdisciplinary field. Chemists, physicists, biologists, electronics engineers, and data scientists need to work together to solve issues including effective sensing that considers the fundamental mechanisms of absorption/desorption, algorithms that achieve precise recognition of VOCs more quickly and with lower energy consumption, and how new technologies such as memristores should be involved. So that's a brief overview of the science behind electronic noses and their potential applications. As you can see, these devices are not just fascinating from a technological perspective, they also have the potential to make a real difference in our lives. Who knows, in the future, electronic noses may become as commonplace as our smartphones or laptops. Please give it a thumbs up and be sure to subscribe for more content on cutting-edge discoveries. Thanks for watching, and I'll see you in the next one.